And I tried doing the whole class at once, and it was really bad. I mean, I put it online, you just can't put it there. Okay, an object is attached to a coiled spring. The object pulled down from rest position is 5 centimeters and released. Write an equation for the displacement if the period is 7 seconds. Okay, so let's talk about springs for a second. Bless you. I'm not sure exactly how into springs are going to get you, but which we'll talk about all these words a little bit later, but let me kind of give you a little preview. So a spring, the position at time t always looks at a, like a cosine, let me just put omega t for now. So it's cosine if you start stretched, which is what usually happens in real life. It's sine if you start from rest. So usually the way people do a spring is when it's resting, they stretch it out and let go. Then you would have cosine. Sine would be like if it was resting and all of a sudden you like shot it with a bullet and gave it, so it started moving from rest. And then, yeah, okay. But anyway, so it looks like this one actually did have sine in it though. But A is called the amplitude. This is just, amplitude is a fancy name for what is the maximum stretch. Omega, it's actually called the angular frequency, which I'm pretty sure you're not going to need to know in this homework, but you will need to know in homework 4 if you don't need to know it now. So it's equal to 2 pi f, where f is the regular frequency, or same thing, it's 2 pi over t, where t is the period. Okay. Those words, so the angular frequency is kind of weird, but the regular frequency and period are exactly like if you've had a science class, what they are. Period is how long does it take to do one thing. Frequency is how many things does it do in 1 second. So, like for, was that?
So the class you teach right before us.
Physics?
This is like physics stuff.
Yeah. Okay, that's good. All right, so going back to this thing. If the period is 7 seconds, so, well, omega is 2 pi over the period. So the omega we want is 2 pi over 7. The object is pulled down and then released. Write an equation if it's that. Okay, so cosine would be, cosine of 0 is 1, and then 0 and then -1. If I want to start at the bottom, I'm starting at -1. So instead of cosine, I actually want negative cosine, right? So it'd be negative cosine and then the 2 pi over 7 guy. Cool. Let's do another one like that. Actually, another word to actual word problems, not just solving triangles. Let's do about let's do every other one instead of every third one. So an object is attached to a coiled spring. The object begins at rest, then propelled downwards. Find an equation for the object. Okay, so this one we're starting in the middle and we're somehow pulling it down. So if we were starting in the middle and going up, that would be sine. So, yeah, sine goes 0, 1, 0, -1. since we're starting at 0 and going down, it's going to be, okay, it's going to be negative sign. So cosine either starts at the top or negative cosine starts at the bottom. Sine starts in the middle and goes up. Negative sign starts in the middle and goes down. Okay, so it's going to be negative sign. And if the period is 5, it needs to be 2 pi over 5. Cool. That's it. Fantastic. Come on. Okay. So let's do one more of these and we'll jump up by 2. Yeah, my picture online still has my long hair.
Oh, no, it's on the board.
Oh, yeah, it's on the board too. Miss Rowland wanted to put like pictures and quotes from all these famous math people on there. I was like, do we really have to put me up there? She's like, it's my board and I'm putting whoever I want to on it. Okay.
Yeah, you listen to this one.
Yeah.
She came to my room one time. I think the first year I came here.
Did you not show up to her class?
I think so,
She used to do that. They don't let us into the dorms anymore. But yeah, used to. She would go hunt you down if you weren't showing up. So. All right. So find the following: the maximum displacement. So again, if I go back to my notes, how do I tell the maximum displacement? Yeah, it's the amplitude. It's the number out front. It's the amplitude. What is the amplitude? 6. Boom. Fantastic. How many cycles per second? So again, the number in front of t is 2 pi times the frequency, right? So 2 pi is 2 pi times 1, right? So apparently this one has 1 cycle per second. And the period, well, it's 1 over whatever the frequency was. So if there's 1 cycle per second, that means there's okay, it's hard to say. Since there's 1 cycle per second, how long does it take to do 1 cycle? A second. So that was kind of silly. But yeah, it's just 1 over whatever v was. All right, let's go to 13. Okay, another one. So basically the same as the last question. What's the maximum displacement? 6. You will be happy though, Michaela, because all of these application questions actually came from the same section in the book, which means there's a lot of the same type of question. So instead of like having 2 questions that are alike and then something different, it's more like 5 questions that are alike and then something different. What's the frequency? So again, the 4, I mean, that's the omega is 4. Yeah, so 4 divided by 2 pi. What? Yeah, 4 to, okay, so this 4 here is omega. The difference between omega and the actual frequency is 2 pi, right? So you just need to go 4 divided by 2 pi. Well, it's 2 over pi.
Oh, yeah, 2 over. That's fine.
I know. And the period, well, it's always just 1 over the frequency, right? So what would it be?
5/2.
Pi over 2. Boom. You have a boil in your ear? Is it? Oh, a pimple.